Welcome, everybody. It's wonderful to have you all here. We have a very special program, and we're going to get started right in because we have a lot of stuff to cover during this really wonderful and special lunch, the Saturday luncheon of the 25th Annual International Space Development Conference. Our featured speaker today is Rusty Schweickart. But before we bring out Rusty and listen to him give the featured talk today, we are going to we have a few very special announcements, some happy awards, and also a remembrance of a valued member of the NSS community. And to cover all of that, I'd like you all to welcome Mr. Arthur Smith, who's the Vice President of Chapters at the National Space Society.
Okay, let me try that. Well, I'm excited to be here again this year, celebrating the work of our chapters. It's always a pleasure for me as the Vice President to receive their reports every year and to hear what they're up to. And then we award those who we see are doing extraordinary things. Can't give awards to everybody every year. I wish, well, Greg Allison, when he was Vice President for Chapters, almost did that. But, we have a limited budget. And so I'm going to go through those awards in a minute. I want to say a little bit about the chapters. We have some big chapters. There's some in the LA area here with some chapters have hundreds of members, some have just a handful, some are just one or two really active people. But they're all working to promote space exploration in their communities or to further the efforts of the society in one way or another. Some chapters have large projects. Some of them take on hosting an ISDC, like the North Texas chapter is doing next year. And there are volunteers working from there. There are also volunteers from the local Los Angeles chapters helping a lot with this ISDC this year. There's, yeah. Give them a hand. So there are chapters around the country and around the world that are doing these things. And there's one chapter that I must make special mention of today. Before we go to the awards, the Sacramento L5 Society, for the last 2 years, was the winner of our Chapter's Explorer Award, which is given for innovative work in furthering space exploration in one way or another, research and development. And under the leadership of their president, Robert Compton, the chapter had been very active. They worked also with John Powell. They worked with John Powell supporting his JP Aerospace airship to orbit efforts. They've written articles. They've done many local advocacy activities, as many of our chapters do. And they also worked on some innovations in rocket motor design. Now, in just about a month ago, while Robert was working on some rocket engine materials in his garage in Sacramento, and despite his long experience with the materials, he had an accident and he was severely burned, and he passed away on April 19th. John Powell is here, and I'm going to welcome him up to say a few words about Robert. And after John will run a short tribute with quotes from some of his friends and a video of their one of their rocket engines doing a test. And there's a memorial, as a memorial to his work. They're trying to raise a bit of money to continue it, put a lot of the work that he did online, make it available to people, and continue some of the other things he was doing. So we'll have an address for that at the end.
Thank you. Just wanted to mention a couple things about Robert. I actually met Robert 25 years ago in Sacramento at an L5 Society meeting that he was the president of. And then maybe 10 years later, I'd moved my company out to New Mexico and was gone for 5 or 6 years. And then I moved back to Sacramento, looked up the local L5 meeting, went to it, and lo and behold, Robert's still the president running the show. He's one of those guys that just keeps at it and keeps at it. And then literally the day before the accident that took his life, we were all together at the L5 Society meeting, and he had just bought some new AV equipment that he was real proud of and planning the new membership drive that he was putting together. You know, Robert was one of those just quiet guys in the background, always working, just dedicated, decades of service that is really the glue that, you know, holds the organization together. And, you know, a lot of us, you know, we hope that when it's all said and done, that we made a difference. Robert's one of those folks, and, you know, if he was out there listening now, we could tell him that we know that he really did make a difference, and he will be missed. Thank you.
Okay. Thanks. Okay, well, now turn to the chapter awards. Our first award goes to a chapter that formed pretty recently. They've been associated with Kennedy Space Center in Florida, and they've shared their enthusiasm with thousands of members and thousands of people in their local area with activities at Cape Canaveral, and most recently for the launch of the Pluto New Horizons mission. Chapter members have also created a new version of the L5 News, available at l5news.org. So please join me in congratulating the Florida Space Coast chapter, winner of the 2006 Chapter Merit for Publicity and Media Award. Fred Becker is the chapter member. Our next award is for a chapter that's worked hard in many different areas. Their website has been exemplary for years and won them an award a few years back. And this past year, through contacts with Russian Space Agency people, they had several items taken on a Soyuz to the International Space Station and brought back. They've run a space school for several years with local students invited to learn about space travel and rocketry, and to see some of the artifacts of the space program and some of these new artifacts they've just created. So this year's Chapter Merit Award for Education goes to the Deutsche Raumfahrtgesellschaft, or German Space Society, which I don't believe we have any members here today. Is that? Okay, we'll be forwarding them this and also their last award, which somehow got lost. In the mail. Okay. Our next award is for a chapter that has held many local events in their area with displays and activities at schools, museums, science fiction conventions, and have reached thousands of people, as many of our chapters do. They recently had one of the members serve 2 missions at the Mars Desert Research Station in Utah. And they've also done various media activities, including video recording, website with with galleries of photographs of the things they've been up to, mailing list that keeps their members informed of what's going on. So this Chapter Merit Award for Community Service goes to the Minnesota Space Frontier Society. And I think the only member here is David Stewart, who's an honorary member who actually is in Seattle. But David's doing the camera, so okay, he'll be down here in just a minute. The other members were too busy doing their Space Day activities to come.
Yes. Actually 2 events they had planned for the same weekend, and they've been doing them for 10 years, so they couldn't back out. So, anyway, thank you. I'll make sure they get it.
All right, our next award goes to a chapter that's also done many different activities. The members particularly held a large number of public lectures and displays. They worked hard on a new display of the lunar surface with a lunar base on it, although I don't think the lunar base is quite there yet. That's for public enthusiasm and bringing people in and showing them how things can work. They've also participated with 2 other chapters in their area in a fundraising event when Magnificent Desolation opened last fall. And actually I'd like all the members we have here from Chicago chapters to just stand up right now. You Chicago guys, come on. They all deserve a hand. The award is to the Chicago Society for Space Studies for all their efforts.
Thank you.
Okay, our next award is the Explorer Award, which I mentioned earlier. And this chapter has also done many public events and displays, which many of our chapters do. But the chapter president took another big leap in leading her chapter and leading space efforts. And let me just read from a report in the local newspaper. Yes, many parents have thought of sending their children to Mars. But Veronica Isabella Alberto of Litchfield Park is the very first Earthling mom actually to have done it. Veronica is a single mother, and she led the Family Living Analysis on Mars project mission at the Mars Desert Research Station last year, bringing her 3 children to live for a week under simulated Mars conditions and under the view of video cameras for a study. So, so we're awarding this year's Chapter Excellence Explorer Award to Veronica and the Phoenix chapter of the National Space Society. Veronica. did promise to take them there every year, though. Okay, our final award today is the coveted Chapter of the Year. This chapter has held lectures and organized pro-space events throughout the year. In April, they led a group of other local space organizations hosting Neil deGrasse Tyson, as we heard last night, who we heard last night. And the event in this case was attended by over 200 people, and Dr. Tyson stayed on for hours answering audience questions, much as he did last night. The chapters also run displays for Earth Day in one of the biggest trafficked rail stations in the world. They co-sponsored an academic conference on astrodynamics. You may have heard of the interplanetary superhighway. That's what that's all about. Ways to travel between planets with very little propellant. They organized events around Magnificent Desolation and Roving Mars, cooperated with other NSS and Mars Society chapters in their area on local events. They prepared newsletters. They worked with the United Nations, where the NSS has non-government organization status, and some of the chapter members are involved in that. And a number have also done political action here in the U.S. with so the impact of this one chapter has been pretty tremendous this past year. It's a chapter with a lot of energy and depth in their membership. Unfortunately, their past chapter president resigned last year, and the new chapter president is moving to Huntsville, Alabama. So I'm not sure where they're going from here, but we'd like to congratulate the New York Space Society as our chapter of the year.
I just left it all. What happened? Oh, thank you so much. That's very nice, very nice. Oh, great.
Okay, how about a hand of applause to all the chapters for all their work.
Thanks, Arthur. That was tremendous. In many ways, the chapters are the heart and soul of the NSS, and it's wonderful to recognize them during this lunch. It gives me great pleasure to introduce our featured speaker this afternoon, Rusty Schweickart. Rusty has brought so much to the space community for so long that it's hard to know where to begin to introduce him. I will try by hitting the major facts and then allowing him to get to the most interesting part of the program. Rusty served as lunar module pilot for Apollo 9 in 1969, the third manned Apollo flight and the first manned lunar module flight. He then served as backup commander for the first Skylab mission. In 1974, Schweickart joined the NASA headquarters in Washington, D.C. as Director of User Affairs in the Office of Applications, establishing relationships with key governmental and industrial organizations that facilitated the use of space technology in fields such as communications, meteorology, Earth resources, and space processing. He was the assistant to Governor Jerry Brown for Science and Technology, as well as the chairman of the California Energy Commission. In the early 1980s, Schweickart founded the Association for Space Explorers, the professional society of astronauts and cosmonauts, and currently serves as chairman for their committee on near-Earth objects. Today, Schweickart is chairman of the board for the B612 Foundation, a nonprofit corporation championing the development of a space system to protect the Earth from asteroid impacts. Please join me in welcoming Rusty Schweickart.
Okay, well, thanks very much for the introduction. Let me see first, can people hear me in the back? Okay? All right, good. So let's start off here. First of all, I want to thank the National Space Society, people in the back room who have together. I'd like to also thank and all of the team from the Planetary Society for the good work they've done in putting together just one heck of a conference, and I think we all owe them some applause for it. Okay, I'm desperately hoping that having sat immediately between Bill Nye and Neil Tyson last night, that a little bit of something other than food rubbed off on me. But don't expect the Neil Tyson show again. Unfortunately, I wish I could do that. I do want to try to provide a little what I call mind candy here at the end of this very nice luncheon. And it's going to be in the form, I guess, of a sandwich, if you will, meat sandwich between a couple of slices of context. Of course, I can't read my context. There we go. Okay, the first thing I wanted to do, having been here for the whole thing, is to acknowledge the tremendous group of people who are attending this ISDC conference. It's incredible. In a way, and you'll see in just a moment as I remark on it, that you're really a very special group of people, and I want to recognize you, and I want you to recognize yourselves for that. Space tourism, for example, on the first night we did the Space Tourism Society, I guess it is, and we had the Virgin Galactic guys and everything else. It's a terrific activity. I got thinking about it and realized that space tourism is a little bit like sex. It's exciting, it's a little bit dangerous or risky, perhaps, and when it's well done, it's tremendously satisfying. But there's more to it than that, because at a deeper level, it's also the basis for reproduction, which is also the foundation of survival. And I want you to recognize that analogy, because the long-term future of this experiment that's going on in our corner of the universe, that we're all involved in, is partly dependent on two critical things. One is getting the human population, in fact, not just the human population. I remember years ago when what we were talking about, moving out into space and that sort of thing, my wife, we happened to be eating strawberries, and my wife realized strawberries are going to be out in space because of us at some point. It's really true. So we'll take mushrooms and strawberries and cheesecake and a few other good things out there with us. And it depends upon, frankly, the evolution of space tourism, which reflects the desire of everybody in this room in one way or another to get out into space. George asked everybody to raise their hands the other night about, who had, who was about to, and who wanted to, and everybody, including, but somebody's wife. Somebody didn't, but 99.9% of the people, had their hands, stood up. That impulse built deeply into humanity is a part of the reflection of the nature of life, to expand and to reach out in every direction until it gets its fingers nipped. And we're part of that, and the frontier in that realm that we're involved in is going out into space. So I just wanted to acknowledge the importance beyond the sort of self-satisfaction, the sexy part of being a tourist in space. That's linked directly to a fundamental aspect of life. Now, it is in fact one of the two primary things that's got to happen if this experiment in our corner of the universe is to continue into the long future. That is a diaspora out into the cosmos. The other thing that has to happen, the second one, is in order to enable time for that, plus to keep the home planet cooking along well, it is to protect the Earth from asteroid impacts. And it's that latter, that second element. I'm leaving the first one up to you guys because I've been there and done that, right? A little bit, right? A little bit. Yeah. And so I'm leaving that up to you guys. But the last 5 years of my life, I've put into the second element of that. And it's that it's that work and that activity that I'm going to be talking about a bit today. Now, I want to work our way into that with a bit of context. This is sort of the theme question of what I'm doing, and the metaphor, the legitimate analogs in this are quite remarkable, in fact. So again, in context, this is the kind of thing that we've seen going on, and starting out with the first keynote in the conference, Charles Alachi pointed out that and in the last session, as a matter of fact, we've all come from stars moderated through comets to a sterile Earth 4 billion years ago, thereabouts, plus or minus. We have no idea the degree to which our relationship to these comets actually exists, whether it's only in the form of hydrocarbons and water, or whether it might be a little more sophisticated than that. That's a very big question in astrobiology that remains open. Nevertheless, this is something that happened, and the fact of the matter is that this rain of comets and asteroids is something which is continuing, and in fact, to the extent that we know, it appears as though the rainfall has been steady for about the last 3.9 billion years. It's not over. We're really in the middle of it. It's just that the raindrops happen to appear with a frequency which is long in comparison with a human lifetime. And therefore, we tend to think it doesn't exist. But in fact, the tree of life grew up in the middle, or let's say in between these infrequent raindrops. They were big raindrops, and from time to time, and in fact fairly frequently, this tree of life has been pruned time and time again, in a sense, by this cosmic gardener. And I want to paint this picture, which is very, very important to get into our heads. That is, that with every 10, 100 million years running into a big asteroid, several tens of kilometers across, or perhaps even maybe once or twice 100 kilometers across, there's been a lot of pruning of this tree of life. And so, as I say, over billions of years, this tree of life gets pruned again and again and again, sometimes very severely. Give you an idea, something like Chicxulub, Chicxulub impact, perhaps 12 to 15 kilometers in diameter. Some of the estimates indicate that among all the other things that are going on, the sky around the whole planet ends up so hot from the debris raining back down in from the explosion that, in fact, about 1 meter of seawater boiled off the world's oceans. When you get up to a 100-kilometer diameter object that hits, now you're talking about boiling off most of the seawater. But in deep vents down at the sea bottom, nevertheless survived in refugia, underground and in the deep oceans, the seeds of life. And once again, just the way in your garden and mine, when you go out there with a machete and hack away at things, you turn your back and next week it's growing all out again. Not only that, it grows out in rather inventive and new ways. And that's exactly what's happened here. So at the moment, we're way out on the end of one of these limbs. I guess I should use a laser pointer, but you just imagine it. We're way out on the end of one of these limbs here. And, the things out around the edge are the ones that are the most vulnerable. Now, you might think, and in fact, to some extent, we are about the most vulnerable of the creatures on today's tree of life. But we have created things, which I point out, are living entities of a sort, and they're even more vulnerable. The global economy, culture, even civilization. These features are more sensitive than even us, at least in terms of extinction. So, we have a lot to lose unless what we do is fire the crazy cosmic gardener. And we now have the power to do that. And the question is, will we step up to the plate? Okay, so let me then go more specifically into what I want to talk about. But my wife insists that I precede things with this reminder. All right, so here we go then in the meat part of this sandwich. You know, when you look seriously at protecting the Earth from neo-impacts and the effect of neo-impacts, you've really got three fundamental components of that process. One is early warning, a second one is a proven deflection capability, and a third is the international decision-making that has to happen in order to provide that protection. Now, we're going to deal with these one at a time, and then we can deal with some questions. I'm not going to go into great depth here, but if you look at the large dashed blue line and just focus on that, forget all the other details, this is the frequency diagram that we know today of asteroids accompanying us in our journey around the sun. Now, I point out here that there are several key things. We're going to be talking about statistical data or statistical information. We're going to be talking about real information or, you know, empirical measurements. Now, this is basically statistical data, and what I'm going to do is compare the early warning process as it has existed up to date, which basically started in 1998 with the congressional directive to NASA to discover 90% of all near-Earth asteroids 1 kilometer and larger over the next 10 years. And so when you look at that, you go up from 1 kilometer and over, and you see that there are about 1,100. That's powers of 10 on the left. So you got 10 to the third, a little over. We got an expectation of about 1,100 of those. But when we go down to the more recent goal set by the U.S. Congress of 140 meters, you come over and you're a little above 10 to the fifth. So in other words, if we take these two programs, Space Guard 1, if you will, and Space Guard 2, and we looked at today, 2006, and the equivalent time in Space Guard 2, in other words, about 75% or a little bit more of the way through, we're going to have about 100 times as many, 2 orders of magnitude more of everything. Okay, the target population is up to 120,000 in that goal. So at 75% complete today, we've got 834 as of this morning in the JPL tables. And in 2018, we can expect, instead of 834 of these objects larger than 140 meters, let me point out that 140 meters is something like a 3,000 megaton explosion of TNT. So you're not talking about something small, and in fact things a good bit smaller than that, probably down to 60 meters or so, can actually do damage on the ground. But nevertheless, the goal is 140 meters, and in 2018 we can expect to see in our database of observed, not statistical now, but observed and tracked asteroids of which we know the orbit and can project. Don Yeomans down here can project ahead 100 years, or some of the guys that work for him can anyway. And no, hey, Don used to be able to. You know. Okay, so now in the process of finding those 90,140 meters and larger, the total that we're going to have observed by 2018 is something like 435,000 NEOs. That's a big jump in the database, and Don's guys are going to have to work their little buns off in order to take the orbits. First of all, a lot of astronomers have got to determine the orbits for 400,000 objects, and then project ahead 100 years to see if there's an intersection with the Earth. Okay, now we do that today, and when you look at that, there's another list in the JPL tables called the risk table, and there today we see, when Don's people have done this, and our Italian friends over from the University of Pisa have done this. Today we find that there are about 105 of the 4,000 total that have been discovered, which have some small possibility or probability, not possibility, but probability of impacting the Earth in the next 100 years. The analogous thing is somewhere 5,000 to 10,000 objects by 2018 that are going to have a possibility over the next 100 years of impacting the Earth. Now, the population didn't change. I mean, if there's a probability then of them hitting the Earth, it's the same probability now. The difference is we don't know about it. And let me point out to you that knowledge is extremely powerful stuff. So what we're really doing with early warning is getting to understand what the existing environment really is. But once you know it, you've got a big responsibility, because you can't just stand back. So you've got to, the big question, of course, is going to come out of the general public. What the hell are you doing about it, right? And where's the answer? Well, the obvious answer is the second leg of that triad, early warning, now deflection capability. All right, so where are we? Well, let me just point out before I go into some of the issues there, that we have had, again, as Don reported a few moments ago in the session just next door, we had a kinetic impact. That's one technique that's available today in terms of technology. We don't need any new technology in order to basically send up a spacecraft and bash into something. And Don did a pretty good job of bashing into a comet. Well, that's an exaggeration, but Don reported on the efforts successfully. I got to say something good about you, Don, because I keep diminishing what you do.
You're doing pretty good.
But the point is that we have now done this, albeit on an object that is probably 5 to, well, linear dimension, 5, 10, 20 times larger than the sorts of things we might want to deflect. Okay, that was a 5 kilometer, right? 5 by 3 or something like that, kilometer object. The European Space Agency has got a mission coming up called Don Quixote. They're in phase A right now. Don Quixote involves 2 spacecraft. The one on the bottom of the slide there is Sancho, which goes up first and orbits around the asteroid, making all kinds of measurements and making sure they know exactly where it is, et cetera, and then it watches the second spacecraft, which is launched separately, not the way we did it on Deep Impact, but launched separately. Hidalgo goes up and rams into the asteroid, and Sancho watches it, and then after it does that, it again finds out and measures what happened, not just things like the crater depth and that kind of thing, but how much change in velocity did that impact impart, how much ejecta was there, et cetera, et cetera. So the Europeans are actually testing or intending to test, it's not fully funded yet, the Don Quixote mission. And I can talk more about that afterward. The second deflection concept, which requires no new technology to employ, is the one developed by my friends Ed Liu and Stan Love, who are both astronauts and members, founding members of the B612 Foundation, which I chair. And in this case, it's a beautifully elegant system where you take up a spacecraft and you don't even touch the asteroid that you want to move. You simply tow it by standing off the surface of that asteroid in the direction that you want to move it, and as we'll talk about in a moment, either forward or backward in its orbit. In other words, you want to pull it to increase its velocity very, very slightly or decrease its velocity very, very slightly. And by standing off, hovering, if you will, half an asteroid diameter off the surface for a month, 2 months, 6 months, a year, using ion engines, which are proven, 2 years continuous operation in space, in Deep Space One, You use a gravitational tow rope, a virtual tow rope, and very, very gently move that asteroid. Now, the beautiful part about it is you don't care if it's rotating, you don't care where the spin axis is, you don't care what it's made of, you don't care if it's a fluffy dirt ball or a dirty fluff ball or whatever other categories these things come in. As long as it's got mass, you can change its orbit very gradually and gently without even touching it, simply by towing it this way. Now, obviously, if you're an engineer and you think about it, it's clear that this is not adequate for anything but a certain cohort of asteroids. I wish I could tell you what the size of that cohort was today. I can't do that. The data hasn't been analyzed. We actually have enough information in the database to make some judgments on that. But the big issue is nobody's got the responsibility for this in the government. Not only NASA, but no agency in the United States, no agency in the world in government has a responsibility for protecting the Earth from near-Earth asteroid impacts. As a result of that, nobody's doing this work. Okay? Don doesn't have the money to do it. I don't even know if he wants to do it. The issue is, until the responsibility is assigned, things don't get done. So there's a lot of data out there. We could know whether it's 10%, 30%, 50% of the potential impacts where these two existing technologies are adequate. But we don't know what that is. Okay. We do know it's not adequate for very large asteroids and or asteroids, even relatively smaller ones, 100 or 200 meter ones, which have aphelions out, beyond Mars. If you get out there at that kind of a distance, the rendezvous problem, and this is something which is generally not understood by people, the amount of energy it takes you to rendezvous with one of these asteroids is generally, not always, but generally larger than the amount of energy it takes to deflect it once you get there. So getting there, in fact, is the larger technical challenge. And to do that, we're going to have high performance propulsion, the kind of thing that was being developed in NASA under the Prometheus program, but unfortunately Mike Griffin had to, with the budget situation he had and the directions he had from his boss, he had to salute and kill a lot of programs that people care about. One of them was Prometheus, which was developing nuclear electric propulsion, and that is the kind of technology that's required, or something equivalent to it, in order to get us out there in the first place to rendezvous with or arrive at, depending on the technique you want to use, at an asteroid that needs to be deflected. So, deflection is half and half. We've got a couple of concepts that will work. We've got technologies that existing are good enough to do those, but we don't have the technology, in fact, to meet the entire challenge. Okay, now let me shift into the decision-making issue. Okay, for those of you who are Stargate fans, and I can hear the laughter, this is Apophis. Apophis is the Greek name for the Egyptian god Apep, who is the god of the underworld or the god of destruction, whatever, and he is appropriately named, or the asteroid that we've named after him is appropriately named, and it is Apophis. Now, Apophis is the blue orbit. I'm not going to do a lot of orbital mechanics here, but I got to do enough so you understand the context in which decisions are going to have to be made about, do we do anything, what do we do, when do we do it, etc. So the blue orbit is Apophis. I've run this ahead to the potential impact time, April 13th, 2036. There's today, I beg pardon?
Is it a Friday?
Is that your birthday? No, it's not a Friday, as a matter of fact. However, I'm about to tell you that, in fact, in order for this to happen, for an impact to actually occur here, in fact, on Friday the 13th, 2029, this asteroid will have to have gone through a very small region in space, very near the Earth, that we call a keyhole. Now, I'm not going to go into that. It's much too arcane and complicated. But what I did want to just point out here is I want you to put yourself on the Earth here. The blue part of Apophis orbit is below the plane of the Earth's orbit, or the ecliptic. The light blue is above. So in other words, I've got the diagram here oriented such that we're looking vertically there along what's called the line of nodes. That is the intersection of those two planes. Now, obviously, the asteroid comes up through that plane and goes down through it, but that's not of interest. When it goes up through that plane every year on the same date, basically, it happens to be the same distance out from the sun as the Earth, as you can see. Now, the real question there is that line, that orbit line, if you just think of the orbit of Apophis as a line in space, okay, that line will cut through the Earth every year on April the 13th. Okay? If you picture yourself going from left to right just before you reach that line and look where the asteroid is, by the way, ignore this location for the asteroid. This isn't the inaccuracies in this particular program that generated the diagram. But it's basically coming along parallel with you, except with a slight converging angle. But when you look outward, away from the sun, you would be seeing Apophis, and as you can picture, as you get closer and closer to April 13th there, it's going to come right through you. Okay? Well, now, whether the asteroid is there or not, that line literally cuts through the Earth every year. The question is, will the asteroid be there at the same time that the Earth is? In other words, will it be on that portion of the line when that line cuts through the Earth? Now, I want to give you a slightly different feel for that, if I can do this without screwing up. Let me try that. Okay. So here we have our good friend Google Earth. Here is my mouse. Let's see if things are working. Yes, they are. Okay. Now here we have the Earth, and you can see if you're looking closely. Let me bring it a little closer. You can see those red marks. Okay. What we've done here is we've broken this. I said that Apophis would have to come through a keyhole. That keyhole in 2029, that keyhole is 600 meters wide. We broke it into 50 12-meter segments, if you will. And in other words, we have 51 points from one end of that keyhole to the other, and each of these dots on the surface of the Earth represents one of those 51 points, and if it goes through that point, it's going to hit at that point on the Earth. So let me just give you a different view of this. You can see that it comes down across the Pacific, but let me just show you a little bit more. If Bill Gates gets my computer moving here. Hello. Okay, well, I'll just do it manually then. All right, so let me just move it this way, and you can see in a way now that this is that line cutting through the Earth. It's, in a sense, it's cutting off the top of the Earth from the direction you're looking now. If I go ahead and tilt it up the other way now, come on, computer, move. Okay. Now you're looking down on that, and you can see that that line wraps around the Earth, and in fact, it doesn't just go 180 degrees. Notice that point 1 over here, just off the coast of Africa, and then 2, 3, 4, etc., out to 51, just at the northern border of Kazakhstan. In fact, it wraps around 270 degrees. Why does it do that? Gravitational focusing. This asteroid happens to be coming in fairly slowly, and therefore it ends up actually wrapping around, the path of risk actually wraps around the Earth. Okay, so this is the kind of thing that one can do when you have the data available that both JPL and University of Pisa and their NeoDice system put out. And of course you can take any one of those points, and let me just do that for a moment. I think I'll take like point number 6 or something like that. Let me just zoom in on that and give you an idea. Now you can see that most of that is coming over the Atlantic Ocean, but some of it is going to be coming in down here, and you can see there's Caracas, Maracaibo. So it comes, again, most of it is over the Pacific, but in fact it crosses land here at Panama and then ends up out into the Atlantic Ocean and ends up off the coast of Africa, as I said. Well, let me go out a little bit and bring the Earth around. Now here's the center of that overall 270 degrees, and you can picture that if you have a hit there, you're going to have, with a large asteroid, which this is, about 900 megatons of explosive power if it hits. You can have a hell of a tsunami. In fact, it is a tsunami which dwarfs the Indian Ocean tsunami, Katrina, and everything else that happened that year, all rolled up into one. You're talking about destruction along the North American coast there, from one end to the other, of about $400 billion loss of infrastructure along the coast. Okay, now, I'm not showing you this to show you the destruction. What I do want to point out is that, and I'll get to this later as well, but let me just say it now. It's a good time to show it. Well, let me just go back to my other graph, actually. I think that's probably better. Okay, there it is, the same line plotted on a standard Mercator kind of thing. And so if you picture that impact point here, then let me identify here some orbital mechanics. Keep this map in mind, and I'm going to give you orbital mechanics light, just adequate here. There's an impact point around here, let's say, on the Earth, and what I've done here in the next click is to draw through space, as if you're standing off the Earth and watching it, actually looking straight down, the path of this impact point and the path of the asteroid going to that impact point. So here in green is the Earth, and in red you got the asteroid, and there's the impact point, okay? All right, now there's the relative velocity, which is, of course, the vector sum of the other two. So in fact, it looks like it's coming in from here. Now, the way in which you move an asteroid, the way in which you deflect an asteroid, is you add, as we said, a little bit of velocity to speed it up, or you detract a little from its velocity to slow it down. Now, how much? I said a little bit. Apophis, because it's heading for a keyhole, you're talking about a micron per second change in velocity. Okay? 10 to the minus 6 meters per second change in velocity. It's a breath of air almost. Very small, but it's extremely important. Okay, and it's a big asteroid. You got 46 million metric tons. So it's a big object. Okay, now when you push, let's say you're going to push with the asteroid's velocity, you're going to increase its speed by a micron or a couple microns, whatever. What happens is you end up with a slightly larger orbit. It takes longer for it to get around, and therefore the asteroid arrives late for the impact at this point. So let's say you initiate the pushing program. Let's just say it's a 200-day campaign. After 50 days, if you stopped, the asteroid would be back here in the orbit when the Earth point got there, and in other words, it would impact back here, not over here where it was headed. If you go for 100 days and then for whatever reason stop, it's going to hit here. If you go for 150 days, in this example, by the way, that's all it is, an example, you get what I call the liftoff point. In other words, it just grazes the Earth. That's over Kazakhstan, if you're talking about Apophis, right? And of course, you have a real target that's somewhere off the Earth. You obviously don't want to just have it graze the Earth. And if you draw a line between those points, you have what I call the deflection path. Well, guess what, folks? The deflection path here on the Earth, across the Earth, is exactly the same thing as the path of risk, which I showed on that map. In other words, as you're deflecting an asteroid, you are effectively dragging the instantaneous impact point across the surface of the Earth until you get it off the Earth, either behind the Earth or ahead of the Earth. And those are your two choices. You don't have a choice of making it disappear. You can try to make it disappear by running into it, for example, in which case it's a one-time maneuver. But if you don't get it all the way off, it's going to end up somewhere on that line. or if you're going to use several impacts, it's going to go bang, 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 okay? So it is that path of risk which is the reality of deflecting. And that is the international decision-making dilemma. Okay, because that path of risk goes across many national boundaries in the general case. This is not a United States problem or a European problem. This is a global problem. And everybody is at risk when you're dealing with the general case. Once you know about something, then you really got a problem, because you have one of those paths of risk, and very specific nations are at issue. But we'll get there. Okay, so let me give you a couple of examples of the decision making that somebody's got to do. Okay, let's say we got a marginal asteroid, a Tunguska kind of thing, 60 meters in diameter. It may not even make it all the way through the atmosphere, but the shock wave is going to come down and blast whatever is down there on the ground. So 60 meters or so is right about the marginal line. Well, let's say that 15 years from now, 2018, 12 years from now, 2018, JPL and or the Italian guys end up looking at this asteroid that we've been tracking for a while perhaps, and lo and behold, it's looking like it's may hit. Serious enough that people are paying attention to it. An in-joke would be Benny Pizer has talked about it. The newspapers around the world are blasting it out, misrepresenting it, making alarm, some of them underplaying it, maybe one or two. So at any rate, you know, something's got to be done, all right? It's a relatively small asteroid. The fundamental question, somebody's got to ask it, okay, do we deflect it or do we take the hit? Okay? Well, now, if you're the hittee, you know what the answer is, you know? Well, the United States ought to go up and deflect it, right? Okay, but we don't know. This is the important point. We don't know where it's going to hit. When you have to take action in general on these things, and again, there are specific cases, but in general, you're going to have to take action when the probability of an impact is something like what? You name it. In fact, that's another decision that somebody's got to make. Is it 1 in 25, a 25% probability that it's going to hit, or is it a 10%, or is it a 5% probability? Where do you start taking action? Because, again, as you make more and more measurements, the probability of impact gradually gets higher and higher. So when do we take action? There's question one. Okay, number two, we're past that point here. So we've got this asteroid coming in, we're going to take action, but what is the action? Are we going to spend money and go up and deflect it, or are we going to take the hit? Where's it going to hit? Who knows? At a probability of 10%, that line that crosses the Earth goes out 10 Earth radii or diameters somewhere in between there in one direction and 10 out the other side. So it could hit anywhere along that line. So when you make this decision, you're not going to know who's going to get hit. So anybody along that line can get hit. Okay, so who makes the decision? Presumably the United Nations. Who pays for the evacuation when finally it comes down to a point if we decide to take the hit? Who was responsible for the loss of property when the decision was made, take the hit? Does the rest of the world community chip in to rebuild the buildings or whatever if it happens to hit over a populated area? Okay, that's just one minor example. Let's take another one. As I said, as you find an asteroid, the probability of occurrence is going to gradually increase. So again, at what probability of impact do you plan a deflection? Okay, at whose direction? By whom? Do you contract with the United States? Do you contract with Europe? Do you contract with JAXA? God forbid, does the United Nations have a deflection program? Okay, and who executes the operation? And for that matter, who monitors it to make sure you don't drop it over somewhere else? Okay? Once an asteroid deflection is initiated, and this is the point that I made earlier, once an asteroid deflection is initiated, the original impact point, legally, an act of God, is shifted across the surface of the Earth. That's an act of humankind until the deflection is complete. Therefore, somebody, some group of people has an increased risk of damage in the process of dropping the risk to zero for everybody. Well, do we move it toward Japan? Costa Rica says, yeah, right? Do we move it toward the Atlantic Ocean, toward South America? The Japanese like that, okay? And a lot of other people, I don't even think. Okay, so that's the kind of question that's got to be answered. When do you answer it? Do you wait until you know a specific one? I hope not, because from timing purposes, it's critical that we do this when we're dealing with the general problem before the discovery of a specific threatening event. Once we have one of those, you got a map like the one I showed. That's just typical. It wraps halfway or a little more around the world somewhere, basically east to west. You're going to have a lot of countries involved, and guess what, folks? If you start making the decisions only then, you're going to have pure power politics, not the safety of the maximum number of people or whatever you want. It's going to be pure power politics. So as a result, and when I say we now, I'm not talking the B612 Foundation. I have another committee I had for the Association of Space Explorers, which I founded back along with some of the other astronauts and a bunch of cosmonauts back in the 80s. And we have last year formed a committee on near-Earth objects, and the specific reason we formed that committee was because as a group of astronauts and cosmonauts, we're dealing here with a space issue, a space technology issue, something that we care about, people, life on this Earth, and we can open a few doors, we can do a few things, and I made a presentation to the United Nations about this situation in February of this year to advise the Committee on Peaceful Uses of Outer Space of the United Nations that this problem is coming down the track at them at high speed. Because again, by 2018, we're going to have 400,000 of these things in the database, and of those 400,000, a couple hundred of them are going to look like they're going to hit us. It's not a matter, I remind you, it's not a matter of whether, in fact, any of those 4,000 are going to hit us. We're going to have to make decisions based upon the appearance that an asteroid is or might hit us. And so there are going to be a lot of them compared with the ones that actually do hit us. If you have to take action at 1 in 100 probability, then presumably 99 of them are going to miss. Okay? Nevertheless, you're going to have to start taking action. So the United Nations is going to be forced in the next 10 to 12 years into making decisions it's not ready for. It's clueless. So we said, okay, we bring in your problem, but we're also going to bring you a solution because we're going offline. We're forming a committee of very experienced international diplomats, former heads of United Nations organizations, heads of space organizations, international law specialists, insurance people, bankers, economists, etc. And we're going to draft, over a period of 2 years, we're going to draft a United Nations treaty and bring it back to them and deliver it in 2009 and say, okay, here's your solution. Now chew on it. And hopefully, out of that, they'll do something. Okay, we worked our way through the meat. I want to go back to context. This is a test. This is a test for humanity at this point in our evolution. And the big question is, are we going to pass the test? Okay, this is a test. This is the entry test to citizenship or becoming part of the cosmic community. We're not going to go out into the cosmos if we don't end up dealing with this. Now, with early warning, I think we got that underway. It's going to get handled. I've got a lot of confidence that that'll happen. Deflection, not so much. NASA has avoided actively anything to do with deflection. Nobody yet has paid attention to it in a serious way, except for our little old foundation, okay? And the Europeans looking at kinetic impact as a mechanism. But that has some serious limitations. So we need to do work on that, and the Congress needs to, first and foremost, say somebody in the United States government is responsible for developing and testing the technology which will enable us to protect the Earth. I think it ought to be NASA, but you could say DOD. And when it comes to making the decisions, the overall responsibility, God forbid, Department of Homeland Security or FEMA. Hey, look, but that's a serious issue. I do care, but let's have the debate. The Congress has got to start that debate. And right now, so far, the wording in what they've told NASA to do pulls back short of that. The decision-making, I think, is the toughest part of the test. That's like the essay test. You know, that's the tough question at the end of the exam. The question, are we mature enough as a species to recognize that we are a life form in this corner of the universe on this little planet that ultimately makes it or doesn't make it to some extent based on this? Now, we may blow ourselves up first. I mean, this may all be moot. Pardon. That was a Freudian swipe of the hand. We may blow ourselves up, sure. But that's not our interest. Our interest is in space. We can stop this. This is not Katrina. Unlike Katrina, this can be prevented. And let me go back again. We know about this. We will have the capability to stop it, to prevent this from happening. Will we do it? The fundamental question there, it seems to me, is have we reached a stage in evolution where we recognize that we're all part of one life system on this small planet, that we have responsibility for it? Do we have enough respect for one another as individuals and as nations? Can we literally love one another enough to make the kind of compromises that are going to have to be made in order to make these tough decisions? Yes, I'm willing to take an increased risk for a while so that the risk to everybody else goes to zero, including me, okay? But that's the kind of decision we're forced into. So there's the final exam in terms of, are we going to make it as cosmic citizens? Now, I'll just let you read that. Asteroids are not unique to the solar system. They're likely around almost all stars. So wherever there is intelligent life, if there is a cosmic community of life out there, they've been through this point. They passed the test. The question now is, are we going to go the way of the dinosaurs, or have we matured? I mean, they didn't have a chance. They didn't know about it. They couldn't do anything about it. So they didn't have to make a decision. We've got past those two first things. But the question is, can we make a decision that ends up allowing all you wackos out there who want to migrate to do your thing? Thank you very much. Okay, I just want to say one thing. The presentation in more detail and stated correctly is available on our website. If you want, you can copy that down. And in terms of what the Association of Space Explorers is doing in and with the United Nations, the lower one will give you that.
Fantastic.
Okay.
Rusty, thank you. I think it's safe to say that with you here and then some of the folks at this table, some of the leading researchers in the world about this issue. Yes, absolutely. That if we ever, when we do have this issue, these are the folks who are going to save the world, and we really appreciate that you're all here. So we have a small gift, our traditional, and we will insert a meteorite, I think, or an asteroid into this somewhere. But thank you so much for coming. I think probably many of you might have questions for Rusty. However, we also want to get our afternoon session started. So here's what we'd like to do. We're going to break, turn up the lights. But if you're willing, Rusty, maybe you could stay here for a few minutes, and then you can answer questions from folks who want to go, but I want to make sure everybody gets the opportunity to start the afternoon sessions.
Yeah, if I don't give a chance here, everybody's going to buttonhole me outside, so I'd rather do it here.
Absolutely. Okay, great. And we have delayed the start of certain tracks until 2:10 or 2:15, so we'll just do that throughout the rest of the afternoon. Thanks so much.